Hi everybody, my name is Neha and I am a member of the Teen Advisory Board here at Howard County Library System. And welcome back to my final video in the Stoichiometry series. If you're looking to gain a more general or basic understanding of this concept, I encourage you to check out my two previous videos. But for now, let's dive right into this video. So this problem says, 76.4 grams of water contain how many molecules? Okay, well first let's determine what we are given and what we want. Well, we know that we are given 76.4 grams of H2O, and we want to convert that into molecules. So, to begin, we can start off by simply putting down what we are given, which is the 76.4 grams of H2O. And for organizational purposes, I like to put it over 1. Now, we have to determine our next conversion factor that will allow us to reach molecules. And in this particular problem, we have 2 conversion factors. So, in order to determine what we're going to put in our denominator right over here, we know that our units, our grams of H2O, are going to have to cancel out. So that means we're going to have to put grams of H2O in our denominator. Well, if we think about this, if we want grams of H2O, that means we're going to have to determine the molar mass of water. So, we know that since we have 2 hydrogens, our molar mass is going to be 2.02 grams, and since oxygen has a molar mass of 16 grams, we're going to add those together to get a molar mass of 18.02 grams. So, now that we have that, we can determine what we are going to put in our numerator. So, since we want to be able to convert all the way to molecules, we're going to have to put a molar value in our numerator. And that is simply going to be 1 mole of H2O. Now, we're only at moles, but we want to get all the way to molecules. So that means in our denominator as well, since our units in our numerator and in our denominator have to match, we're going to put 1 mole of H2O right there as well. And in our numerator, we know we're going to have to put some value of molecules. But the question is, what's that value? Well, this value we see over here, 6.02 times 10 to the 23rd molecules, is called Avogadro's number. And this number is universal all throughout chemistry, and it's a numerical value that represents molecules, atoms, and particles. So whenever your problem references these 3 terms, you know to use 6.02 times 10 to the 23rd, and this will be the value you insert into your problems. Now, since we have set up all of our conversion factors, we know if we multiply and divide out that we are going to get a final answer of 2.55 times 10 to the 23rd molecules of H2O. Now let's move on to the next one. This problem says, how many grams of calcium carbonate are required to prepare 50 grams of calcium oxide in a decomposition reaction? Well, if we think about this, it might sound a little wordy, but all the question is explaining is what's in this chemical equation right here. So, let's determine what we are given and what we want. Well, we know that we are given 50 grams of calcium oxide, and we want how many grams of calcium carbonate are going to be required. So let's start off by writing what we are given, which is the 50 grams of CaO. And again, just for organizational purposes, I like to put it over 1. Now we're going to determine a conversion factor that will allow us to switch all the way to a totally different substance. So we know that our units have to cancel out. So since we have grams of CaO up here, we're also going to have to put grams of CaO right here. Well, just like in our previous problem, if we have to put a grams value of something, that means we're going to have to determine the molar mass. So calcium has a molar mass of approximately 40.08 grams. Oxygen has a molar mass of 16 grams. So if we're going to add this together, we get a molar mass of 56.08 grams per mole. And that is the value we're going to put in our denominator. Now, let's determine what we put in our numerator. Well, we know that we want to convert from grams of one value to grams of another, but we can't just jump over a bunch of stuff. We have to go in an orderly fashion. And in order to do that, we have to convert from grams to moles and then go through more steps in order to reach grams of calcium carbonate. And one of these intermediate steps is going to be to convert from grams to moles. And that's what we did right here. By placing a 1 mole of CaO, we have converted from grams to moles. And now we're going to take another step to convert to calcium carbonate. So we know that since we have 1 mole of CaO up here, we're also going to have to put moles of CaO down here. And we know to put 1 mole because if we take a look at a chemical equation, we only have 1 mole right there. And in our numerator, this is going to be our big conversion factor that will switch between the calcium oxide and the calcium carbonate. So we're going to have to put 1 mole of calcium carbonate because we only have 1 mole of that as seen in our chemical equation. Now, at this point, we've reached moles of calcium carbonate, but we want grams, so that means we have to go through one more step. And right here, since our units are moles of calcium carbonate, that means we're going to have to put moles of calcium carbonate right in our denominator as well. And we want grams of calcium carbonate, so that means we're also going to have to figure out the molar mass. And we can do that right here. So calcium again has a molar mass of 40.08 grams. C has a molar mass of 12.01 grams. And oxygen has a molar mass of 16, and we're going to multiply that by 3 to get a total molar mass of 100.09 grams per mole. And at this point, we have reached the end of setting up our problem. And the final step we have is to multiply and divide out. And if we do that, we're going to get a final answer of 89.2 grams of calcium carbonate. So this problem is one of my favorite problems because it ties together all the skills we worked on. So that's the end of this video. I hope this video and this series was helpful to you, and I hope you learned something new. Thank you so much for watching. Bye!